Okay, welcome back everyone. Today we'll be looking at the CCC 2022 Junior number 5 square pool. And this is the problem. So Ron, he wants to build a square pool in his square yard. And his yard has some trees, and my job is to determine what is the maximum length of the square that he could possibly build. And that's pretty simple. So the first number is the size of the yard, and then it followed by the number of trees in the yard, and then he will give you the coordinates of the trees. And what we want to find is the maximum length of the pool that could possibly build. And like this one, it's a 5x5 grid, and there's only one tree at the location 2, 4. So y coordinate first, then the x coordinate, and with one index. And we can build a 3x3 pool over here. Let's jump right into our code. So we're gonna use IOStream and include the vector and include the algorithm. So we will declare two set of vectors represent the four dimension of the rectangle. So we're gonna name them top, bottom, left, and right. It means literally. And then A and C. A is the size of the yard, and the C is the number of the trees. And coordinate X is the X coordinate of the tree he's planting now, and the coordinate Y is the Y coordinate of the tree. And record the size. This is because how our code is working is that for each tree we're gonna put it in all the possible rectangles that's available to us, and then for we're gonna use that tree to split the rectangle, and it will form 4 small rectangle. And so for each tree it's like one round, and for each round what does the recording size do is it keep track of how many squares are currently available for me to later to do loops through each round, and to know that each round how many cycle of loop do I need to do. And so we'll first take the input, and then we're gonna begin with our initial big rectangle. So the dimension of the first rectangle has the top and the left, they have a coordinate of 1, and the bottom and the right, it depends on how big the rectangle is by the input. That's where we're gonna begin. And for each tree we will take the coordinates, and then we are going to begin our cycle of splitting the rectangles. So okay, so this is looping through all the rectangles that's available, and this is the current rectangle we are looping through. This 4 dimension is this, and then we're gonna compare our coordinates and the dimension of the rectangle to see if the tree is actually inside the rectangle that we are currently examining. And if it is, we're gonna check if this is it is on the edge, or it has a distance of 1 with edge. We are not going to consider it because it's just too small. And yeah, to just save some time. and this is outside. So this one we go back, and this is a function we declared in the earlier. So what it does basically is to remove any duplication of the area rectangle we split it. How it works is that after I split the rectangle, I'm gonna check if this splitted area is already inside the previous big rectangle we have been dealing with. So this is just a loop through kind of the first path of the big rectangle that we already split it, and we check the dimension. If this is inside, that means that this area has already been appeared in a big rectangle that we have already been split up. So we will not be adding this area again. Otherwise, it's going to be returned true. So if these two conditions are both true, we are just going to add this splitted area. And since we are using the tree to split a big rectangle, imagine a tree inside a big rectangle is going to form two smaller rectangles. This one at the top and left, right, and bottom. Each one has a rectangle, and that's basically how it works over here. Or if the tree is not inside our current rectangle, we're just going to put the rectangle back to our second vectors, just doing nothing. And this is okay. This one is we copy the number 2 vector, which where we contains all the splitted area, and we make the first one back into the we just make the first one equals to the second one, and we just, in order to restart the loop, and this is clearing up the second vector. And then after we looping through, we are going to check. So this part, in case of there's nothing inside the vector, so I just assume that the side length we can possibly build is just 1, and we exit the code. And then the last one is just looping through. And so we have a lot of rectangles. So how we find the maximum length is that because we want to build a square pool, that means that a square inside the rectangles, it depends on the shorter side of the rectangle. And what it does is the bottom minus the top. So this is the side length if you look vertically, and this one is the side length which you look horizontally. And we pick the minimum value, and this is just a maximum collection. And we are just printing out our result over here, 1 or the max we are collecting, and that's it. Thank you.